Hello there. In this video, I'm going to talk about how you can, with the Earley Parsing Algorithm, it's possible to build a parser that gives you user-friendly error messages. In the case when there is a syntax error. So this video is going to build on top of the video that I made that introduces the Earley Parsing Algorithm. So if you'd like to get an introduction to that, I would recommend that you find that video and watch it first. One of the things I said in that video is that with the one of the advantages of the Earley Parsing Algorithm is that it makes it possible to straightforwardly give very user-friendly error reporting. And this is actually one of the reasons that I got interested in the Earley Parsing Algorithm. I actually had studied several different parsing algorithms and parser generators, and I liked Nearley.js in particular because it used the Earley algorithm, which I studied, and I realized this was the one that allowed me to straightforwardly implement user-friendly error messages. And so a while back, this was July of 2019, I wrote up, I first sent an email to the creator of Nearly.js asking him would he be interested in a feature like this, where if the user of the parser, and the parser would be the front end to either a programming language or some sort of parser. It could be a JSON parser or whatnot. When there's a syntax error or a parse error, you would be able to show the user essentially what the parser is thinking at the time that it encountered an error. So this is the example that I gave. If you got this input of JSON, which is erroneous, the Earley parser would actually be able to tell you what it's thinking. So it is, in this case, it says instead of a string, this one, which is a string token, instead of a string token, the parser was actually expecting to see either a closing curly bracket or a comma, and it actually explains why it thinks that. It expects a closing curly bracket because it was in the process of matching an object as first a open bracket and then a list of object entries, and then it's at the point where it's expecting a closing curly bracket. And why is it in, like, how did it get to this point? Well, it was from this previous rule where it was matching an object, and then that in turn was from this previous rule where it's matching an array items, and then which in turn was from this rule where we're basically inside a series of array items, which basically here, this opening square bracket that started from here, and you can actually see the tokens that were matched. Like this one was based on here. This object entry list is actually currently being matched, and we're in the middle of this object here, and this opening curly bracket is here, and it's actually has matched these guys. And we have currently, once you've matched name colon Marty age colon 8, we actually have a complete object entry list, and a closing bracket would close out the object. And so it's expecting a closing curly bracket to close out this object here. And it's also expecting a comma, because a comma would allow you to add another key value entry to this object. And the hope is that upon seeing this explanation of what the parser is thinking, the user would able to realize his mistake. In this case, the fact that he forgot a comma. Okay, so that's the error reporting. And this is a feature that I asked the creator of Nearley.js whether he would be interested. He said he would, and it resulted in this pull request, which made it into Nearley.js. So if you check out the latest version of Nearley.js, you would get this error reporting. And I'm gonna show you now how that algorithm or how that error reporting actually works. So let's go back to the example I showed in the first video where we use this grammar. Again, it's very simple grammar which can match addition operations. And we compiled this grammar last time into JavaScript. So if we want to test an input with this grammar, then we just have to do this, npx nearly test, the name of the JavaScript grammar file, and then -i, and then I can put in an input. Last time we tested the input 1 + 1, and that gave us this table, this parsing table, or the parsing chart. To refresh your memory, the chart at index 0 means this is the set of rules or set of states, more correctly, but the states are sort of like these stateful rules that have a progress, namely this dot, right? This is a cursor. And basically at the 0th state, you set up these rules to start progressing, and as you're matching tokens from the input, you're gonna try to move these dots up within the rule to sort of advance the progress of each individual rule. And we already did this whole thing by hand, so I'm not going to repeat that. But basically, the 0th column is when no inputs have been read. The first column is when we've read the first input, in this case, the string 1. And the second column is when we're reading the plus symbol. And the third column is when we're reading the second 1 symbol, like that. Okay. Now, what if we put in some wrong input, such as instead of 1 + 1, we're gonna put in 1 + n, which at the moment that's not possible in this grammar because it just doesn't allow for alphabet letters. So if we did that, then this 1 would get crossed out, and we'll get an letter n instead, and this become invalid. Okay, and so at this point, when the parser gets this input n, what is it going to try to do? It's going to try to look at the rules in the previous column to try to find a match, a rule where the next thing that's coming, which is like the thing to the right of the dot, matches the input. And in this case, we're going to look through each one. So this, and it's only going to try for the ones where the thing to the right of the dot is a terminal symbol. Term is not a terminal symbol. It's a non-terminal symbol. So it's not going to try that. And number is not a terminal symbol either. So the only thing that is a terminal symbol is that, which says it needs to be a digit. And that's not going to match the n. And for that reason, the parser needs to fail here because there's no rule that allows the character n. So then what does the parser do? Well, the error reporting scheme that I've shown you, what it actually does is just instead of trying to sort of explain why n is not allowed, it actually shows you all the things that it thinks should be allowed next. So all the things that it's expecting. So what are the all the possible characters that the parser expecting? Well, we just need to iterate through these rules and find all the rules where the next thing coming after the dot is a terminal symbol, and that is the third row here. So given this, we can say I'm not expecting the character n. Instead, I was expecting the character, well, not character, the character class, a character matching the character within 0 and 9. Okay, and then the parser is actually going to try to explain how it got this answer. And the way it's going to do that is by trying to first show you this rule. So it'll show you this rule. It can actually render the dot. First, it displays this rule, but then it actually wants to show you how we got to this rule in the first place. And that would be the rule coming before this rule that generated the rule that needs to match a number. And if the dot is at the very beginning, the way to do that is to just search within this same column 2, for a rule where it's waiting for a number. And in this column, there are 2 of them. I'm gonna go with a different color so you can see. So there are 2 of them. This one and this one, they're both looking for a number next. And the error reporter will just pick one of them instead of trying all the possible different combination. It'll just pick one of them. It doesn't actually care. So let's pick the shorter one of the 2. So it'll write term like that. So essentially what this does is explains that, well, we're trying to match a number because we were trying to match a term, and a term was determined to be a single number. Although there are a couple of possible solutions to that, but we chose the one where a term expands to a single number. And then, but it keeps doing that. So how did we arrive at term? It does the same thing. It looks in the same column because the dot is at the beginning of this rule. It looks again in the same column for a rule where the next thing that's expected is term, the thing on the left hand side, and it finds it here this time. This is the first entry. It finds it here, so we'll copy it down here. And this is the recursive entry where a term wants another term within it. And this is coming from index 0 this time. So in this case, the dot is no longer at the very beginning of this rule. And when that's the case, we know that this rule actually originated in a earlier column of the table. And from which column? We can find out from this from index. The from index brings us to the 0th column of the table, and that's where we're going to start to search now. Where within the 0th column do we have this same rule starting? And the answer is that one. So this one is the one that matches. But we're actually not even going to copy that over because this is the same rule. So I think this is this is done. Like if we had copied that over, it would just look like a redundant entry in here, like that. And I think that's not super useful to the users, so we're just gonna leave that at that. Okay, so that's a very simple, very short example of what the error reporter is doing. And this is what the error message actually looks like if we gave to the parser this erroneous input. As another example, I have example 2, where this grammar can match terms, more complex terms, inside of a parenthesis due to this rule here. So it can match things like this, for example. So let's try, go to the command line and try to parse something like this. I'm gonna use the example 2 grammar this time. Oh, I think this -i should come second. So it can parse something like this. And this is the chart, and it's a substantially larger chart than the other one because it's more complicated. And that makes sense. Now, what if we had messed up the input? So let's see, if we say put a letter in here, what will happen? Well, it's gonna tell you that character N is unexpected. Is that I was expecting to see one of the following. It could have taken a open parenthesis here. So instead of an N, maybe, you remember, it hasn't seen anything. It could have taken another open parenthesis to maybe add yet another group here, like that. So that's a possibility. And it'll explain why that's possible, because we're in the middle of matching an unary here. So like an unary is expecting at this position, and maybe an unary is a parenthesis and then another term and then a close parenthesis. Where did it get the idea of trying to match an unary? Well, it was trying to match a term. And a term can be an unary and then a plus and then a term. Now, where did it get the idea of matching a term? Well, it was trying to match a term here. It was trying to match a term here because it's in the middle of this one. You can see the dot here. The dot here is actually in the middle here, right after having matched this plus sign. You can see this plus sign has been consumed. It's coming after the dot. So after it has seen an unary and then a plus sign, the next thing it wants to match is a term. That's how it got to the point where it wanted to match this term. So that's one possibility. Another possibility is it wants to match a digit, a character matching the character class between 0 and 9. And then again, it explains how it why it thinks that. Now, if we go back to the version of the input that actually worked, and we review the parsing table, we can actually see why we got those 2 expected characters, because we can count how many input characters were in at the point where an error occurred, right? So because what we did to change this input was we changed a 3 to an N. Okay, so and the 1 is at index 1, the plus is at index 2, the open paren is index 3, the 2 is index 4, and then the plus is index 5. So the time where we encounter the N, we should have had the 5th column here ready to go by the time we encountered N. And of course the other entry we're going to ignore because we're looking at an alternate history at this point. So when we're getting N, basically what the parser is going to do is search in the previous column, in this column 5, for other rules that could possibly match the input n. And again, it couldn't find any. But the only rules where it was looking for a terminal symbol were this one and this one. So one of them is trying to match a left paren, the other one is trying to match a digit. Thus, the two possible expected characters in the resulting output. Okay, so I'm going to wrap this video up here. I hope this explanation of how the error reporting works in Nearley.js made sense enough. If you're a user of Nearley.js and you're reading these error output, we would like your feedback. Send me a YouTube comment or something, or anything. Reach out to me or Kartik, because we do have an interest in making the user error messages helpful. So your feedback would help our job in doing that. That's all I've got for you. Thank you for watching.